Good morning, folks. How's everybody doing today? Sorry we had technical difficulties today or yesterday. I think I've got it all worked out. Let's see. I did notice you guys, for the most part, did a really good job on the chapter 2 homeworks from last week, so that's great. Some of you started on the ones for this week, and that's good. That's good. That'll help. I do want to have a talk about mean, median, and mode today, but then start talking about our measures of spread as well, because they really do need to be looked at together. But before we do that, as always, is there anything you guys want to ask or look at before I, dive into a spiel?
Are we gonna go over this little guy? Because he's not my friend.
He's not your friend? What did he do to you?
He won't tell me how to use him.
In particular, you're trying to do with him that he's being
the next assignment, like 3.2, I believe it's using of the calculator, the graphing calculator.
Yeah.
I don't understand what those symbols are. Like my friend Jesse was saying, it's Greek, and then it's like, how do I make this work to make it?
Only some of it's Greek.
Okay. Yeah.
Some of it's Roman.
Oh, that's
nice. Yes. Yes, we will. Let's see. Do I have? I'll have to update that so I can use it. But yes, we might talk more calculator tomorrow than today. Because we'll essentially talk a little bit more about doing things by hand today, and then bring the calculator in to help us tomorrow, and then Excel to bring Excel in to help us on Thursday. So that's kind of my progression plan. We'll certainly play some with the calculators today, though, but we'll get all that in there. So. But it kind of depends on which things you're trying to do with it. Oh, there comes everybody. Hi, everybody. Any particular symbols in there, though, Camilla? You said some of the symbology there was causing you trouble?
Oh, yeah. I don't know what any of that stuff is. I'm on section 3.2 looking at problem number 1, and I'm like, I don't know what's going on there. So I just
they were starting
to cover material that gets me through that homework.
Yeah.
Okay.
Definitely.
Okay.
Yeah. Yeah, that's less calculator stuff than more just kind of like us having to talk about what some of that symbology stands for.
Okay, let's do it.
Okay. So what we're going to be chatting about this week are some of our descriptive statistics. So as the descriptive statistics, remember from last week's statistics, does mean we're talking about measures of samples. So we're going to be presuming that these are samples, even if that sample is the entire population. So we're going to be using our symbology that is specific to samples and statistics as opposed to parameters. Remember last week we had that distinction between a statistic and a parameter. A statistic was based on a sample set of data, where a parameter was based on the entire population of data. So we're going to be presuming we're talking about samples as we go through chapters 2 and 3. Why do I have a B there? I don't know. Just to be silly, apparently. Thank you, Kit. So the first set of descriptive statistics we're going to talk about are ones that measure center. So measures of center. Measures of center is a fairly technical term. They're essentially finding specific values that can stand for the whole. So if you have a whole set of data, like say everyone's height, and you want one value that's going to kind of take the place for everyone's heights, we generally call that an average. So these measures of centers that we're going to talk about are essentially different types of average. Now, often one of the first things that's a little bit of, I almost want to say a barrier here, is that we're used to thinking of average as one specific thing. And the idea that there are multiple types of average is one of the first things that we have to get used to. And one of the things we want to talk about are some of the differences between them and why they are, well, some of them are more advantageous than others. So let's start just by grabbing a set of numbers here. I'm going to make up a set of values here. 3, 3, 5, 6, 7, 7, well, 7, why not? 9, 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 values. Now these 9 values have a certain amount of spread to them. In the next sections in chapter 3, we'll talk about spread. But for right now, we want to talk about center. We want to talk about average. Now, generally, when people hear the word average or learn about the word average, there's a very specific technique that one thinks of. Generally, we think of the idea that we could add them all up, divide by how many we have. How many of you have used that or seen that as a way of finding average? Most of you guys are like, yeah, great. So if we add all these up, we could find their sum of the values. Now, we're going to have to find sums a lot. So if we're going to have to find sums a lot, having to write out find the sum of is going to be kind of irritating after a while. So it might be nice to have a symbol that stands for add all these things up. And we have such a symbol. We go to the Greek alphabet and grab the Greek letter sigma. It's essentially the Greek capital S for sum. And that Greek symbol sigma says essentially add everything up. So if we see something like sigma x, it just says add up all our variables, all our values. So Camilla, that's probably one of your first symbols that you were looking at. This is, I don't know about that. This is sigma, and it stands for add them up. Sure. So if we wanted to add up all of these values, we get what, 3, 3, 6, 12, 17, 24, 38, 47, 57, is that true? Yep, all right. So the sum of our values is 57. If we wanted to find then the average that we're used to thinking of, we said there were 9, right? 9 values. So the sum of those x values divided by n. So take that 57, divide by n, our number of values. Number of values. 9. And that's going to give us a nice value for average. And let me see, that'll be 6 something, 6.3, 3333, I would guess. Is that right? You guys have calculators in front of you. So that 6.333 is one of our types of average. And this is a type of average that we will use a lot. This type of average is referred to as the mean average, or just the mean. Sometimes you'll also hear it referred to as center of mass. You'll hear it referred to as weighted average. We'll use it later as expected value. So some of those words or phrases are equivalent. So yeah, expected value is a good one. Expected value, weighted average. Other ways of that we will talk about mean average. Now, one of the reasons it's called weighted average, and what makes the mean, what makes it special, is it's finding that sense of center based on the values of the numbers we have. So it's taking into account the fact that that biggest number is a 10, the smallest number is a 3, that there's a value of 5 in there. It's using those values to find a center based on those values. So it's got a little bit of a process to it. It's got a process of finding a sum. It's got a process of using division, using arithmetic, because it cares about what the actual values of the numbers are. But let's say we wanted a simpler measure of center. We've got 9 different values here. If we just look at those values in order, and I asked you what number is in the center, what number is in the middle, do we necessarily have to go through this kind of big arithmetic process for you to tell me what number there looks like it's in the middle? Just looking at it, what number looks like it's in the middle? Got some 7s popping up there? Yeah, it looks like there's a 7 in the middle. That if we look at that 7 there are 4 values above it. There are 4 values below it. That 7 certainly does look like a type of center. And it is. Our median is a different type of center. It is the, I'm going to put middle here in quotes because it's kind of a weird word here, the middle value. Very specific though, when data is in order. So having our data listed in order here was very handy. Alejandro, you said it's 6.7. Is it supposed to be 6.7 or 6.3? Is this 6.3? Okay, cool. I just want to make sure we're all on the same page. Okay, so the median is that middle value when we put the data in order. So that 7, our median, is just that, 7, that middle data point. Now, not only is in some ways that easier to calculate, but it does give us a center based on a different logic. It is our center based on position, based on order. The median doesn't care that those smaller numbers were 3s and 5s and the bigger numbers were 9s and 10s. It's not affected by larger or smaller values on the outside. All it cares about is what value is in that center. Does that seem reasonable? We'll talk about why that has advantages and disadvantages as we go along. But it does make it distinctive. And we'll often talk about the mean as being an average by value, because the values matter, where median is an average by position. Because all that matters is its position. But before we do, there is one other type of average for us to talk about, and that is mode. We will use mean most often when we talk about average. We will use median a fair amount. We won't use mode all that often. There are a couple cases where we will, but it'll be our least common. But mode is very simply the value or data point that happens the most. That happens most often. So that might seem a little bit less like a measure of center, and it is a little bit less a measure of center. But remember, our idea of average is to find a value that's going to stand for the whole set. So if we want one value that's going to stand for the whole set, why not make it the one that happens the most often? So if we look at that data set, what number occurs the most often? Well, there are 2 3s. Everything else happens only once except for the 7s. The 7s happen 3 times. So our mode would be those nice 7s. Why? Simply because it happens more often than any of the others. That does bring up some natural questions. What would happen if there were only 2 7s? Well, we could say there are 2 7s and 2 3s, and we could say that this set was bimodal. It had 2 modes, a mode of 3 and a mode of 7. Okay, what if there wasn't a 7, but there was another 9? That's a 9, I promise. Now, we could call it trimodal, I assume, but after a while, we just start to say, okay, there's just no mode. Nothing is significantly coming up more often than anything else. If there's 2 modes, bimodal is fairly common, but worrying about whether there are 3 or 4, we generally don't. It's generally, if there's 1, that's our mode. If there's 2 and we're interested, we might start talking about bimodal. But if they were, say they were all different, let's say this was a 7.1, a 7.2, and that was a 3.2. Okay, then there's just no mode. And that's all right. So oftentimes, particularly when we're dealing with continuous data, it's very common for there just not to be a mode. And that's okay. That went away. So those are our 3 types of average. I do want to look at some things that can kind of go a little bit wrong with each of them and some of the strengths of each of them. But mostly I want to first talk about why they're all important, why we have different ones for different reasons. Before we do that, though, any questions on any of the labels or any of the any questions on any of that before we look at some examples of strengths and weaknesses?
I have a quick question, and
Yes,
it's probably going to cover it in probably in the next few minutes.
that's okay.
The letter symbols with the N, a small n as opposed to a capital N. Now, would the question dictates whether or not we're referring to a small n for a sample and a large n for population? Would that depend upon the question that being asked?
The short answer to that question is yes. It will depend on the question that's being asked. We do use that small n for sample size. We won't use the capital N very much for population size, but it does come up. We do have the sigma that we want to get used to. That's our sum symbol, just essentially to, again, means add them up. For right now, median and mode, we will be writing out. Median sometimes will abbreviate, but not very often. We will later have a symbol that we can use in place of median if we want to, but it really doesn't have a shorthand. Mode also doesn't. Mean, though, I'm kind of glad you brought that up because mean does have a shorthand. It's X for when X is our variable. So if we're calling all of these different values for X, our mean is X bar. We do read that symbol, X with a little line on top of it. We do read that as X bar, and that will be our symbol for a sample mean. So the kind of formula that we have over here, we'll often see it written as X bar is the sum of the values divided by the sample size. So X for our values, little n for our sample size, sigma for add them up, and then X bar for our mean. Does that help? I kind of went further with that, but.
No, that's good. It helps. It's just I have to learn to speak a new language. That's all.
You do. That's true. That's part of what we're learning. Okay, so let's imagine we've got we have 5 people. And these 5 people are trying to decide where to go to dinner. And they all can afford different amounts for dinner. So one person says they can afford or want to pay $5 for dinner. Somebody else agrees and says, hey, yeah, let's find some place where we can spend $5 for dinner. Somebody else goes, hey, I want to spend $12 for dinner. Somebody else says, I'm up to $15 for dinner. And the last person says, $15 each for dinner. And the last person says, I want to go spend $30 for dinner. I know, there's always that person, right? And so they're trying to decide what to do. Well, somebody there might suggest, let's find the average amount and you can go get dinner with that average amount. Does that seem like an unreasonable response? Now, that would be a fairly simple thing. Hey, let's just find the average. But again, we have multiple types of average now, right? So I want to look at what happens when we find and use our different types of average. So let's start with finding our mean. So take a moment and find the mean of that data. Again, that's our X bar equal to the sum of our values divided by our sample size. So take a moment and find that mean. Tell me what you get. Michelle, you got a 13.4. Alejandra, another 13.4. Good. Anybody else want to agree with that? All right. Now that is $13.4. Now that 13.4, if we use that 13.4 as an average, and we say, okay, everybody, we're going to spend 13.4, how well does that 13.4 represent that entire group? There's a lot of different ways to answer that. It's not bad, but do notice it is larger than 3 of them, right? Why is that 13.4 larger than more than half of those people? And it's because of that 30, right? That 30 is pulling that average value away from the 12s and the 5s. Let's imagine this wasn't 30. Imagine instead that this person had said, say, 70. Would that 70 have an effect on our average? Have a huge effect on our average, right? This is the issue, good or bad, with finding a mean, finding an average by value. Extreme values tend to pull off, our technical term, tend to skew averages by value. So whether or not this value is a good representative of the whole depends on what we're trying to represent. Now I'm going to put that 30 back there for a second. An example of this, a fairly extreme example of this, is things like home price. If you go out and say, okay, I want to buy a house I'm in Medford, so you want to buy a house in Medford. So you ask, well, what's the average home price in Medford? Well, you go and you could look it up, but if you go and sample a whole bunch of houses, you might find a bunch of houses that are, 185,000. You might find some houses that are, 225,000, some houses that are 315,000. And, you know, you might find a bunch of those. You might find, say, 4 of those, and you find 5 of those, and you find 6 of those. And then you find that one house that is $3.2 million because it's up in the hills, right? If you average those together, what's that $3.2 million going to do to that average? It's going to jack it up, right? And that average would probably be, I don't know, we could actually, you know, math it out if we wanted to, but that would be higher than likely all of those, just because of that one large house. So using our mean average might not be good for finding things like what is an average home price, because there's always those couple of big houses up in the hills. This is also true for income. If you look at what is the average income for, say, people in the state, well, most people make, you know, fairly reasonable livings, anywhere between, you know, $20,000, $40,000, $50,000 a year. If most of the people in your state make, say, around $50,000 or $60,000 a year, but then there's those couple of CEOs that are making, you know, $10 million a year. Again, what's that going to do to your average income? It's going to do that same thing. It's going to jack it way up. And you'll see people say things like, hey, the average income in our state has gone way up. Well, yeah, but does that mean the income for the average person has really gone up? Maybe it does, maybe it doesn't. Mean is not a good way to find a measure of average, a measure of center, when you have extreme values. What would be better? Well, let's look at median. Now for this data set, that median is just that nice $12. Does have the advantage that we're not having to do much calculation. And it's not that different from that 13.4, right? It's a little bit less. It does put 2 folks below it and 2 folks above it. But what would happen if we changed that 30 back to the 70? What effect does that have on the median? Absolutely none. You could say, no, I want to spend $170 on dinner because you're just that kind of person. What does that do to our mean? It would have a huge effect on our mean. What does it do to our median? Again, absolutely nothing. Median is referred to as a resistant measure because of this. It is resistant to extreme data. Same thing for home prices. If we put these home prices in order, there were, say, what, 11, 15, 16 of them. So the middle would happen somewhere around the 17th. So the middle, I think it's going to be one of these 12 or one of these 225K houses. That would be our median. Well, that is a good median. That is a good average. That is a good, you know, just kind of standardized value for that home price. Fair? And again, for income, if you have, you know, 200 employees that each make $15 an hour and one CEO that makes, you know, $10,000 an hour, it's disgusting. The mean average, that $10,000 an hour, is going to make that mean average income spike way up. But the median is going to be one of those 15s. So oftentimes when we have extreme values, median can be a lot better as a measure of center than mean. Now, on the other hand, let's say you were the restaurant itself, and the restaurant needed to calculate how much money it's making. And it has 5 customers, and those are its 5 customers. And it wants to know how much does the average customer spend. Well, the average customer spending $13.40, they're actually getting that money, right? If they have one customer that comes in every once in a while and spends 70 bucks, well, that's actual value that they receive. Fair? So that mean might be more representative. Similarly, if you're the county and you're trying to figure out the average home price for property tax, that one $3.2 million house is generating a lot of extra property tax. So in that context, the mean would be more representative. So when we want mean versus when we want median is really going to depend on what we're studying and why we're studying it. The fact that median is resistant to outliers, okay, that's good if we want those outliers or want those extreme values not to corrupt our data. But if we want those extreme values to matter, then we have to use something that cares about them. Fair? So oftentimes you'll get some questions that will say, you know, which kind of average do you want to use in this scenario? And then you'll get a box or a section that says, describe why you wanted that type of measure. And oftentimes, either type of measure is a perfectly reasonable answer. The right or wrong in that question is, how do you describe why you want mean over median? Fair? So it's the justification that's more important than the actual answer. And that might be intimidating, but that's okay. It's where we're trying to grow here, right? So mean and median will often have this battle between, well, which one do we want? Do we want the measures of value or do we want those measures of position? And we'll talk more and more about that as we go along. But we haven't talked about mode in a while. As I said, we won't talk that much about mode. But there's one big place where mode is important. Let's imagine we ask the question, let's say, what type of drink does the average, and that's our keyword, the average McDonald's customer order? Now, again, I've used the word average there, and we have different types of average. We have a mean average, we have a median average, we have a mode average. If we wanted to find the mean average, well, we'd have to add up all the different types of soda and divide by how many sodas we ordered, right? How do we add 5 Cokes plus 7 Sprites plus 5 waters? Can we add those together? Okay, so mean's off the table. We could look at mode, but for mode, we have to put our data in order. What comes first? Sprite or root beer? they're not ordered naturally. Fair? Why can't we use our mean and our median on those? Why does the idea of order and value not make sense with our types of drinks? What is it about that data that makes those questions even silly?
It's categorical data.
Good, Andrew. It's categorical data. We can't perform meaningful arithmetic on them. Now, we could assign them numbers. We could say, hey, you know, the Coke is in slot 1, the Sprite is in slot 2, and we could add those together and find an average, but that average of, let's say, slot 1.7 is not meaningful. So what would we do to figure out which type of drink is the most common? Well, which is the average? For categorical data, mode isn't necessarily the best type of average. Mode is the only type of average that we can use with categorical data. So we'd have to say, well, which is most common? And I looked it up once, it is Coke. So the average is a good old cup of Coke. Is it because it's the middle in order? No. Is it because if we add them all up and divide it by how many we had, we get the value of Coke? No. It's because it's the one that occurs most common. And it's the only type of average we have for categorical. That really is mode's major advantage, is that it works on categorical data. Questions about that? So, and that's the main reason we won't use mode much, is because most of the data that we'll work with, a lot of the data that we will work with will be numerical data. But categorical data comes up a fair amount. And when we want to find its average, we go with mode.
Matt, I'm got a small question maybe.
Great.
I know that you looked up the average is Coke, but could that Coke or any other drink, could the restaurant owner assign each drink being popular or not?
Could assign, what was that last part?
Could each company assign which drink they feel would be the popular, or does it have to be proven?
Well, they could certainly say anything they wanted to.
Okay.
If it's going to be a true average or a true mode, it should be based on some sort of sample, some sort of data. The place I looked it up wasn't actually from the company. It was from somebody who did sample data.
Okay. Because my store might sell more Pepsi than Coke.
Yeah.
I don't know. Maybe I'm out there too far.
Um,
Let's move on. Sorry.
okay. But for it to be a mode, we should be collecting from data, which means it should be provable.
Okay. All right. Thank you.
So let's look at when things go wrong. That's always fun, right? So what can go wrong here? Well, let's again grab ourselves some data. Let's say it's just some random data here: 7, 3, 5, 8, 9, 1, 2, 3, 4, 5, 9, so 6, 4, 1, 2, 3, 4, 5, 6, 7. Yeah, let's just stop there. So let's say we have that data. and somebody says, find the average, well, we know we can't just say find the average anymore, because you'll ask, well, what type? So let's see about finding the mean, the median, and the mode. Maybe it would be good for us if I started to use that X bar for the mean more often. Force you guys to get used to that. So take a moment with that data, find X bar, find the median, find the mode, and we'll talk about what kind of things can go wrong. So you guys seem everybody who's mentioned the mode has said no mode. And no value occurs more than once, so that's pretty comfortable with that. Does seem to be some argument about the median. What do we have to do before we decide the median?
Put them in order.
Good. I'm glad nobody said 8, right? 8 looks like it's in the middle, but does require that set to be in order. This can be, it's not too bad to put data sets in order when they're small, but you can probably imagine, if your data set is really large, putting them in order might be a pain, but that's what Excel's for. Excel has a nice feature to just automatically sort everything for us. And that comes in really handy. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So if we had like 400 data points, we wouldn't have to order them by hand. You just highlight it, click sort, and it orders them for us. So that's going to be nice and handy. So once we have them in order, that median is the one in the center. We'll often refer to the median in terms of the 50th, oops, I shouldn't say percent, the 50th percentile. Percentile is a word we hear fairly often, right? Depending on what your background is. But that 50th percentile, it should break the data set into 2 pieces that are the same size. So just as many below are median as there are above our median. So, yep, pretty happy with that median being 6. The mean, we'd have to add them all up and divide, and it looks like you guys are all getting 6. Everybody comfortable with 6? What was the sum?
$42.
So you added them up, got 42 divided by 7, and that gave you 6. Okay, that all seems nice and reasonable. But I did say something goes wrong, right? So what goes wrong? Now, nothing's wrong with any of that. That's all right. But we find out that at least those are wrong. Somebody comes up and tells us that this mean is actually 7.2. And the reason it's 7.2 is because we are missing a value. Now, that wasn't our fault. We didn't have the value, right? But are we curious what that value is? I'm glad Isabel's curious. A couple of you are curious. We were missing a value. It fell off the truck at some point. We know the average is supposed to be 7.2. We know all these other values, but we don't know that missing one. Do you think we have enough information here to find that missing value? It's always a dangerous question because my next comment is often, well, then find it. Okay, let's find it together. What do we know? We know the sum of the values divided by how many we have should be our mean, right? We know what the mean is supposed to be. What's the mean supposed to be? Well, it's supposed to be that 7.2. Okay, 7.2. What's our n? Throw it out there.
8.
I got some gang symbols flying up. No. I got 8. Yeah, it was 7, but we're missing one, so it's now an 8. That's good. And we don't know the sum anymore, though, right? We know part of it, though, right? We know if we add all these together, we get how much? We get that 42, right? Plus this missing value. I'm just going to call it our last x value. Can we solve that for the x? It's a little bit of algebra here. You'd have to multiply both sides by that 8. See what that sum had to be to make it work. But at 56 plus a fifth of that is 56, 57 something. You guys have calculators? What is it? 57.6? 57.6. Okay, nice. Thank you. So 57.6, that's what the total sum had to be. Well, for the total sum to be 57.6, we can subtract off that 42, subtract off that 42, and find that that missing value was, what was it, 15.6? So, hey, we got that missing value, 15.6. Is that horrible? Common homework problem, though. So do be ready for that. Is that going to change our mode? It had the potential. If it came up as one of our other numbers, then it could suddenly give us a mode, but that doesn't match any of our other numbers, so it's not a mode. Is it going to change our median? At least potentially, right? Because now when we put this list in order, still 3, 4, 5, 6, 7, 8, 9, but now it's 15.6. 1, 2, 3, 4, 5, 6, 7, 8. So that changes where our center is. Fair? It also does something else. Our last two examples of median, we had a nice number in the middle so that there were the same on both sides, right? Because even before this, oh, where did my thing go? Yeah, where'd it go? Yeah, even before this, our 5, 5, 12, 17, 30, there was that one right in the middle because this was an odd number of values. This is now an even number of values. We don't have a single number in the middle. We essentially have these two trying to kind of make up that middle spot. Fair? If we want one number for a middle that's going to break this in half, it's going to happen between those two. Fair? Any suggestions on how we want to find a value in between those two? Well, 5 isn't between 6 and 7, though.
I would add them up and divide by 2.
So wait a minute. You're saying you want to use our mean average of our two center points to find our median average?
Yes.
Well, you're right. That's exactly what we do. We find the mean of those, or the mean average of the two center points. So it would be 13 divided by 2 would be the nice 6.5. And that median would then be that 6.5. And that 6.5 sits in between, and notice again breaks us into two sets that have the same number of values in them. 4 below, 4 above, just like this was 3 below, 3 above. There is a big difference though. Notice here, when you're talking about breaking it into the below and above, this is going to be really important later. We grab all the values above, all the values below. This 6.5 just made that boundary in between. But on the odd number set, that 8 that makes the boundary in between, that 8 is excluded from both of those sets. The 8 isn't in the lower set, the 8 isn't in the upper set. It's the boundary between them. This is going to be real important in the end of this week. So we do essentially have two different protocols. One for when our data set is even, and one in which we have an odd number of points. Fair? So that's the biggest thing that goes wrong, is that sometimes we have to do a little bit of extra work to find our median. Something else to notice here, we are trying to come up with a value that stands for the whole again. But notice that even though most of these are nice whole numbers, it's perfectly okay for our averages, even our median, to be decimal values. You know, the famous example is, you know, the average family has 2.5 kids, and a lot of jokes about, you know, having, you know, that half a kid you only care half as much about. But it's perfectly fine for averages of both types to be to not be values in your set of data. The only counterexample to that is mode, because mode is the data point that happens most commonly. It has to be an actual data point. But that's one of the reasons we often don't have a mode. Questions about any of that? Okay, let me give you something to chew on a bit, and then we'll talk about something different. Another fairly standard homework question. Let's say they usually talk about in terms of tests. You take, let's say, 4 tests and an average of 6%. What in percentage do you need? On the last test, assuming all the tests are weighted the same, what score do you need on the last test to average a 90%? A fairly common type of question. Notice I've been a little bit vague about average. Do you think the type of average we're talking about here is a mean, a median, or a mode?
Probably a mean.
Probably a mean. It certainly doesn't have to be a mean. It could be a median. It's the idea of it being a mode would be kind of weird. But usually when we talk about averaging things like test scores, the actual value of the tests, you know, the values you get on the tests matter, right? We're not just grabbing the test that's in the middle. And, you know, the problem with it being median is really, even if we got a really high score on the last test, it probably wouldn't affect our median all that much, because the values don't matter when you're talking about median, right? So this is very most likely a mean-based question. Now your text is going to be fairly nice to you and say mean when it means mean and median when it means median. But once you leave this, you know, class and you're talking about average in other contexts, oftentimes people won't be specific. And you'll have to kind of pull from the context of the question, which type of average are they talking about? So that's something to kind of look forward to. So I'm going to give you a couple minutes to kind of chew on this a little bit, try to decide what you would do and how you'd approach it, and try to find what score you'd need on that last test to average 90%. I really need A there, average 90%. I'll give you a couple minutes. Right back. You guys talk about it amongst yourselves while I was gone. You can, you know. Okay. What do we know that before we take the test, we know that our average is 86%. So that means the sum of the first 4 divided by 4 equals 86, right? Which means the sum of the first 4 was whatever 4 times 86 is. Was it 344? Is that right? So 344. So that's what we're told. What is it we want? Well, we want an average, a mean specifically, of 90%. That means, oops, E sigma, the sum of all 5 divided by 5 has to be 90. So the sum of all 5 has to equal 450. So that means 344 plus the last test has to equal 450. Track that off. That means the last test would have to be, at 106. So I hope there's extra credit. Generally, there's not, though, so don't count on it. But what would we have to get a 90%? We'd have to get, well, you would need 106%. So if we assume a maximum of 100%, so not gonna happen. That ended up being a depressing problem. Now, we knew it was going to have to be a good score, right? Because we had to have that percentage go from something lower to something higher. And averaging 86 on 4 tests, how much can one test help us out? Apparently not enough. Questions about that process, though? These do take some practice. Make sure you're getting that practice in there. Your homework for this section, I think, only has like 5 problems. Be sure you're kind of playing with those and going back in and getting some of that experience.
How did you get 450? How'd you get that number?
Multiply both sides of that by 9. So if this divided by 5 was 90, then 90 times 5 has to be that sum.
Okay.
Fair? Anything else? Okay. Before we let you go today, so I want to talk about spread. Averages, all the types of averages, are only so useful. Only so useful. Yeah, pen's being weird. And why is that? One of the, there's lots of examples, but one of the examples that I like to bring up is back when my daughter was just born. Doctors love throwing data at you, love throwing averages at you, because you have a lot of questions, and so they try to throw stuff at you. But one of the examples were things like walking. When should the little tyke start walking? And they say walking at an average of, her doctor told me, an average of 11 months. Now, of course, what type of average is that? Is that a mean? Is that a median? Is that a mode? I wasn't even going to ask the doctor that. I presumed it was a mean, because that's what most people mean when they say average. Now, I do want you to keep an ear out if you're listening to the news or listening to other sources of information. Keep an ear out for that word median. 10 years ago, you didn't hear it that much, but nowadays when they talk about particularly salary, income, or home prices, you'll hear them, instead of saying average, you'll hear them say the median income or the median home price, because they're trying to get a little bit more savvy. And it really is kind of interesting. 10 years ago, you almost never heard it. Nowadays, almost every time they talk about home prices and income, they'll specify median. So keep an ear out for that. But presuming that that's a mean. Now, my first question when they said, walk at an average of 11 months, my first question was, what is that standard deviation? Now we'll talk about what standard deviation means in a second here, or a lot tomorrow also. But I remember I had one doctor who actually responded to that. And that doctor said, I remember hearing that word in school. I was like, I'm not going to find out, am I? So this is the problem with the statement of they will walk at an average of 11 months. So your little bundle of joy is 11 months and 4 days old and isn't walking yet. What do you do? Well, that's over the average. So you panic, right? You go, it's 4 days over the average. My child has a neurological disorder, and you start freaking out. Somebody else's child is 10 months and 27 days, and that kid's walking. Well, how do you respond to that? That kid's a prodigy. Sign them up for the Olympics. That's a horrible smile. Oh my gosh, it's creepy. Do not smile about your children that way. Right? Anything less than the average means they're walking early and they're a prodigy. Anything above the average means you should be panicking. Is that right? It might be right. It depends on how spread out that data is. Now, okay, clearly for babies, it's not. When I was asking about standard deviation, I was asking about sense of spread. What is essentially, what is the plus or minus on that data? Because if it is 11 months plus or minus a day, then yes, freak out and celebrate. If it's 11 months plus or minus 2 months or 3 months, then we don't care that your kid will walk through, you know, and no, don't worry, it's okay. Fair? So just being given information about center and not having that idea of center be including a sense of spread is really, really disadvantageous. Fair? So what we want to talk about tomorrow is, instead of measures of center, I want to talk about measures of spread. So we can start, you know, dealing with this issue of, well, okay, that's the middle. You know, what's the rest of the data look like without having to have all the data? And just like we had 3 types of center, we are actually going to have 3 types of spread. We had mean as our center by value. Remember, the values mattered. So extreme data threw it off really easily, or extreme values affected it very dramatically. So we are going to have a measure of spread by value, and it's going to be called standard deviation. Literally measuring how much we deviate from the standard value. Standard deviation, how much do we deviate from standard? How much is our spread? And that's going to be our spread. Again, though, by value. So those two will essentially match up. We'll talk about those two together. Similarly, when we talk about median, median was our center by position, we will have a spread by position. And it's going to be our IQR. We'll talk more about that later. Stands for interquartile range. But right, how spread out it is between our quartiles. We'll talk about what quartiles are probably tomorrow. So that interquartile range, that will be our spread by position. So one of the reasons I'm going through this way is I want you to associate these. When we talk about mean, we will pair mean up with standard deviations because they talk about center and spread by value. When we talk about median, the median will be associated with the interquartile range. Those go together. We tend not to mix these. Talking about median and standard deviation together, that would be weird. Talking about mean and interquartile range together would be weird. They're talking about different things, so we don't tend to mix them. And then, of course, we have our mode and range, and these we'll just call our oddballs. Mode is average by frequency, range isn't spread by frequency. These are just kind of the other two. Mode is really easy to find, it's just the most common. Range is really easy to find, and both of these, frankly, aren't very useful. So we'll talk about the existence of range, but then we'll use it for almost nothing. We talk about what mode means, but we won't use it a lot. So you can kind of keep these on the fringe. But mean and standard deviation, that's a pair we're going to use throughout the entire class. Median and interquartile range, that's a pairing that we will use not as much, but a lot, to give us a sense of spread. Why do we want that sense of spread? Well, it's essentially like it is with the babies here. Just knowing, or toddlers, or whatever you want to call them, just knowing the center doesn't tell us as much, or doesn't tell us really anything about what's normal, what's typical, what we should expect. You know, you should expect your kid to be walking at 11 months. Well, there's no way the kid's going to walk at exactly 11 months to the hour, right? What's my sense of spread? What's my sense of normal, typical? What's atypical? What's unusual? None of that information is contained in the average. You mix average and spread, you suddenly get ideas of normal, typical, usual, unusual. You can talk about percentiles. You get all kinds of information by mixing center and spread. Fair? So that's where our conversation is going to start tomorrow, and that gets into your 3.2 standard deviation. 3.2 does have some of the more crunchy calculating bits in it. So be prepared for that tomorrow. It'll be fun. Any questions I can answer for you guys before you trundle off today? I'm going to look over your labs today. So those scores should change sometime today. Oh, do check your registration status. All the administrative portal stuff is supposed to be up now. So go look at that. Make sure for not only this class, but all your classes, make sure you're registered in what you think you should be registered in. We can still fix anything we need to fix, but it's easier to fix the sooner we know about it. So I've got you all on My Open Math, so we'll be okay. but just go check your registration status and make sure it's all what it's supposed to be. Okay? If it has any issues, let me know. We'll fix it. Okay. You guys have a wonderful day. Do send me anything that you need. I do have some questions I'm going to respond to later today on the messages. But overall, I'll see you guys tomorrow. You're very welcome. Camilla, is there anything you need? You doing all right? All right.